So for this video, I've been working on different ways of having some type of mist or smoke kind of drifting across the floor of a scene. And what we're looking at right here is my first attempt. And what I did for my first attempt was to take that Bezier curve code that I showed on my last video and added some smoke particles to it and did a couple things with it. So I'll go over that technique first because it gives a certain look. Not bad, not exactly what I was kind of going for, but it looks pretty good. So what I'll do is talk through the VXF graph that I'm using. So there's a couple things that I want to show you on this. One thing I learned, which is very handy, is how to collapse these down. When you get a lot of different nodes on there, they take up a lot of space. And if I just double click on one, you can see it expands and you can see all the inputs and outputs and operate on it. But if I double click on it again, it will collapse back down. So it's handy for just making better use of the space. And I think that's new. I've never noticed it before, but I found that. So I wanted to point that out. Another thing I wanted to point out was this subgraph that I made. So I started making more subgraphs, which also are very handy because in this case, what I wanted to do is I wanted to have different particles modify my position of the control points on my Bezier curve. So if we look here, I have control points pos 1, pos 2, and pos 2-1 and 2-2. Those are my control points. And if you remember, the control points control the curve of my Bezier curve. And so by shifting them, it will cause different elements of the smoke to follow a different part of the path. And that's what I wanted to do to make it not just one single stream, to kind of spread out in somewhat fairly random fashion. And so what I did is I am offsetting these. So if we just look at one of these, I'm taking the output of this 1 of 3 noise and I'm adding it to the X component of my position. So I'm taking the position, adding to the exponent some random number that comes out of here, and then I am setting that for my position 3, which is the control point of my second Bezier curve. So I do that 1, 2, I do it to my other Bezier curve down here, my first one, right there and right there. And so this is a fairly large item. Drag it over here so we can just take a look. So what it's doing is it's taking the input ID number, dividing it by 2 to use as a coordinate of 3 different Perlin noises. So I have my 3 noise elements, and then what I'm doing is using this, which I haven't used before. It's a switch statement. So it's taking the ID number, which is going to be 0, 1, or 2, and if it's 0, it will take this value and pass it through. If it's 1, it'll take this value and pass it through. And if it's neither one, which is 2, it will take this element and pass it through. So it'll basically pass through 1 of 3 numbers. You can see the numbers right there in this case, and pass it out for offset 2. And then it does the same thing for offset 1. So there's a lot of nodes here, but when I put it into this graph, it just shows up as one node. So it's a way of taking maybe some complex computation, similar to what I did with the particle along Bezier curve that I showed before, this tangent. I convert the tangent to degrees that I can use for one of my rotations. when rotating my particle along my Bezier curve. If you want to see that, if you watch my previous video, I go over making that operator and all the details of this Bezier curve. So then I take those values, and of course I set the position, which moves the particle along the Bezier curve using that branch. And again, I went over this details in the previous video. In this case, I'm also adding a purlin noise to the X component. So I'm taking my time, dividing it, so it basically moves the noise along slower, and then I take this random noise value and I add to it. So it'll be a different amount of value per component, and then I feed it into, again, the coordinates and use what comes out of it to add. So this component is unique per particle, just like that ID number is unique per particle. And I set those right here. So these are two custom attributes. If I select it, you can see the attribute name. Again, they're custom attributes as shown here. I just named them. One is smoke value, the other is unique particle that I use as my inputs. And I like to do that to give some unique path for every single particle to give a bit more randomness. So again, they're not all just following the same path. Lastly, what I did is, again, I didn't need this add angle because I don't really want the smoke to turn as it moves through the path. I do use that in some of my other techniques, but in this case, I just want it to float along and just move, but not actually turn. It didn't look natural, so I didn't want to do that. And I use a modification of my other shader. In this case, what it is doing is it's going to take a mask and it's going to and it onto my input smoke, and then it's going to fade it. I found that you can't get too fancy. I'm not sure why or how it exactly works, but if you try to have too many changes in your shader for every single cycle and every single frame that it's animating, it just doesn't take them into account. So in this case, all I really wanted to do is to take away the rough edges of my smoke. I didn't want any of the edges going to my smoke. So what I did is I created this, what I called soft cloud. And how I did that is I used Inkscape. So this is the Inkscape program. It's very handy. If you don't have it, it is open source. You can download it for free. Just search for Inkscape. But it's nice because it's a vector-based program. And what I did for this is I simply created a circle. And then you can go down to this blur, and then you can crank up the blur, which again softens the edges. And so in this way, it will remove any hard edges from my that smoke that I passed in, because that's really, you don't want that when looking at it. And you can see from the scene that there are no hard edges. I also add a random, come up here, set a random angle onto it just so they're not all facing the same direction. Gives a bit more unique look to each one. I did also set a scale to make them start out a little bit bigger. This is a key one, this set size over life. So they start out small and they get much bigger at the end, which I have found with smoke, especially as you make them bigger and make them fade away at the same time, it really adds to that nice effect. I multiplied the whole size by 11 to make them a lot bigger. And again, this fade amount, and I've showed this before, but that shader is very similar to ones I did before, where I'm subtracting a number from the overall value that I'm multiplying it by my smoke. And so I start out with a pretty high number. So they start out pretty much transparent. Then they get less and less transparent as it moves along. And then it gets more transparent, so they disappear at the end. I really like it coming in partially transparent. That's why you don't see them kind of popping on. They are appearing, but they're almost invisible. And then they become more and more visible as they go along and get bigger. And then at the end, you'll see they kind of fade into nothingness. They grow bigger, but then they kind of fade away. And so that really gives that soft look as they appear, and the soft look as they disappear. And I suppose I can again, there's nothing fancy. There's nothing moving here because again, what I found is when I was moving things, it just didn't have any effect. And so I'm just taking really the input texture, which is I'm passing in my smoke. This is just a default. This is what I pass in for my soft mask. I add the smoke to my soft mask to mask all the edges away. And then this is my basic noise pattern that I'm going to use to fade away, again, to give a bit more randomness. This clamp is very important because when you're anding things, when you're multiplying these things together, the numbers can get big or small, and it kind of messes up the fade. I found when I didn't have this clamp that my fade just did not work as expected. So again, that's going to clamp it to make sure that anything less than 0 is 0, anything greater than 1 is 1. So these numbers coming out will always be between 0 and 1. Then, of course, I subtract my fade amount, multiply by my my pattern and that soft mask in order to get, and then I clamp that to make sure that's between 0 and 1. And then, of course, I use that for my alpha, multiply that by the color for the actual base color. So that is attempt number 1. Again, I like the look. It's not exactly what I was going for. So on my second option, I wanted to use a trail. So I wanted to stretch the smoke, which gives a completely different look. So I'll go over that next. So this is my second attempt or variation of our smoke going across a floor. And what I'm using here is I'm using strips. So I have my same particles, which I just have set to a size of 0. And they're trailing strips. And I like the look of it. I mean, of the stretched smoke tends to look nice. I mean, they are all the same. Kind of reminds me of ghosts kind of springing up. But one issue is that you'll notice like right here, you see they start out really short and they grow long. And then all of a sudden they take off because that's the particle moving and the smoke is stretching along the length of the strip. And so you almost have to have the start off the edge of whatever effect you're going to be using. So by the time it reaches a visible portion of your scene, that the strip is fully extended, which should be easy enough to do. I simplified it. I'm just using one Bezier curve instead of the multiple ones. And what I did is I exposed a good number of items. So here I have my curve variance, and I'll show the I'll show the VFX graph in a minute, but the curve variance is going to move and pick a random number to move both this position and this position. And I have it set so this position will always move in. So it'll pick a number between 0 and -1. This will always go in the positive direction between 0 and 1. And so it gives some variations. It's not great. I mean, they tend to cross in the middle. You'll notice there is this start variance where I pick a number from -1 to 1, and it varies this start point. So that's why you get this spread of where the particles are starting from. And I use that same number for the end. You could use two different ones. I just happen to use the same one just for speed. Then I set the lifetime. So that's the length or how long the strip stays alive. So that affects the length of the strip. And the rate, just the number of strips per second. You can play around with those numbers. And then the speed, how fast they move up across. And as you change the speed, the lifetime needs to be adjusted also, because the slower it goes, the shorter they will get with the same lifetime, just because they stay alive longer. Makes sense. So now let's take a look at the VFX graph that I used. Let's give ourselves some room. So it's actually a little simpler than the other one. Here's all my exposed variables, of course. And here's how I'm using them. So what I do is I made 4 custom properties to hold the offsets that I'm going to be using to control my Bezier curve. So here I just call them offset 1, 2, start offset, and end offset. And you'll see I'm using this curve variance for the 2 control points. And if I expand this one's going between 0 and 1. This one's going between 0 and -1. And the start variance goes between -1 and 1. So it can either go to the left or the right of the start, and I use the same one for the end. So essentially I'm just taking that variance that you plug in, multiplying it by the random number, and I get the actual offset that I'm going to change those start and control points. And here you'll see that I'm just taking the end, I multiply it by the end offset just in the X direction. So if we look at our scene, and I select this, you can see that this is the red is the X direction. So it's going to move them left and right, not forward and back. That's the Z direction. So they're going to move left and right by that curve variance amount. And I do the same thing for the other ones. I just take the other custom attributes, offset 1 for the position 3, offset 2 for the position 2, and then this offset, start offset for the position start. So in that way, when you change those values, then it's going to shift for each particle, per particle. And that's important when you look at the random number, because you'll notice this constant is unchecked, which means 1, it's going to pick a random number with a random seed. Constant means that with the same seed, it will use the exact same number. You'll notice I can't even set a seed if this is unchecked. So that's what you want, just to get a better random number each time, and it's per particle, right? Not per component. If it was per component, it would use the same random number for every single particle. And I want different numbers for every particle, so each one traveling will travel a different path. It's really the idea. Then, of course, we're using this trigger event rate. So this is triggering 10 times a second. That's what this 10 means. So for every second that the particle moves, it will create 10 particle strips. If I made this too low, the particle strips would be kind of chunky, which sometimes you want. If you're doing like an electric arc effect, you may want it more zigzaggy. I want it more smooth, so 10. You don't want to make it too high or else you're just wasting and creating way more strips than you need to. And then I have to rotate the particle. Actually, I'm not even outputting. And just for testing, I did set the angle to make it flat, and I set this to a bigger number so I could see the particles as I was debugging. But I just set it to 0. You could even remove this whole particle quad if you wanted to, because I'm not outputting the particle. What I'm doing is I'm outputting the particle strips. So of course we want to inherit position. I don't know how the particle strips, I had to rotate 90 around the Z direction, which if you think of that, what it's doing is rotating around this axis. And if I didn't do that, it would be standing on end and not flat. So that's why I had to rotate 90 around the Z axis. Of course, my lifetime I'm using for the lifetime of the strip. So that says how long each strip particle strip will live. I don't need to update it at all. I used the size. So what I did is I used the ribbon width that you set, and then I did a sample curve just so it starts out really small and then grows bigger, just so while it's being created, I didn't need it very big. And then I just used the set color over life. Again, I didn't use any fancy shaders, just the default shader. I used this smoke 6, my one smoke, the same smoke image that I was using for the previous example. And then the color, I just made it semi-transparent at the beginning and the end here. So, and then I made it fairly transparent in the middle, fairly gray, because I didn't want it bright. It's supposed to be smoke. So, so here the alpha is 0 at the beginning, 0 at the end, and just not even full strength even in the middle. So as you can see, what happens just if I play around with some of these numbers, if I increase the rate, I can watch to see the result, to see if it just gets too much. If I shrink the start variance, you'll notice that they are more packed in the middle and at the end. So you can kind of now see actually my Bezier curve. It's wider because of this variance of these guys on the outside. If I even decrease the variance, you'll see it gets even tighter. So you can see by playing around with these values, you can actually control the actual look of your scene to get the kind of look you want. And it's okay, nothing great. Not super impressed. I mean, it's, again, if you play around with some values, it may get the look you want. Decrease the rate a little bit. It's not that bad looking. So next, first I wanted to figure out, you'll notice that I didn't have to do any rotation of my strip. And if you watch one of my other videos, I showed that sometimes it was necessary in order to get the strip not to be really skinny. The fact is that the default strip orientation is wide in this direction. And so I didn't really need it. And if you really curve sharp, it did get a little thinner. But I'll show you another example where I needed to. So if I rotated, if I made this strip go from this side to this side down the x-axis, I would need to do some rotation. So I'll kind of show an example of that next, just in case If you're laying it out and you can't figure out what's going on, that's why, and I'll show you how you can fix that. Okay, so what I'm showing here is just a sample that I made to kind of highlight the issue of rotating your ribbon item. So what happens, just from my observation, is whatever direction it starts moving in, it seems to orientate the width of the ribbon in that direction. So Unity tries to make the ribbon wide in the proper direction. But then what happened is when it's changed direction, it kept going. The width is going in this Z direction here. And so as it moved down, it got thinner and thinner and thinner until the end. And we may not want that. So you can see it kind of, that's really what it's doing. So we don't want that. We want it to stay wide the whole way along the path. So I can show you basically what I did. I generally just took a copy of exactly what I was doing before. We see I have the same Bezier curve, the same variance. I'm not using them for this example. But what I am doing is I'm using this tangent in degrees. So if you watched my last video, I went over in detailed making of this subgraph module. And really what I did is I took the tangent, which is part of the normal standard Bezier curve node, but it outputs it in a direction, and I want it in a degree. And I went over the details of this in my previous video, and I'm not going to go over that. But essentially what I'm using is I'm converting that to a degree, and then I'm setting this direction variable. And this is a built-in property. It doesn't set it to anything. Unity doesn't set it to anything. I thought maybe it would set it to the direction of the particle, but it doesn't. And the manual basically says you can use it for your own to load up the direction however you want. And the key is that I use the direction mainly because over here in my particle strip, I can inherit the direction. And what's important to know is that I can't just drag a line from here all the way over to here. That doesn't work. These variables are part of this system. This is a separate system, and you have to inherit items from this system to this system in order to get them in here. And you can't, from what I could tell, you can't inherit a custom attribute or property. It has to be from a limited set, and direction is one of them. So I inherit the direction. And what I did is I didn't hook this up, and I'm setting the angle. I'm rotating around the X in order to get it flat. And if I hook up this Z, remember our angle that we took from the tangent, because the tangent is the direction that the particle's moving at that point. You can see now our particle strip is always the same width all the way around because I'm rotating, right, the particle that it's using around using that tangent direction. So the tangent here is in this direction. I'm using that angle is really between the direction and how much I want to rotate it, so it always stays wide. That's exactly what I want. And the reason it's a solid white, if we look at this, is my output. I'm just using the solid square. It's just a white square. I use it. It's very easy and useful to use in this situation because you can see exactly how wide that particle strip is, and I just hard-coded a size. So that's a useful thing. If it's generally not needed if you're not making sharp curves and going in different directions, but it can make a difference in some situations if your Bezier curve gets really sharp. And I noticed it while I was doing, following some of the other videos on an electric arc, which also used the Bezier curve. It got really thin at the ends, and I could never quite figure out why, and I think that's why. So just another helpful trick that you can use when working with particle strips. All right, so on to the next one. All right, so next I wanted to, instead of using a Bezier curve, which kind of controls, and it's always going to kind of move in that curved direction, which you may not want, what I thought was using some of the noise nodes instead. So there's no Bezier curve here. So what I'm doing here is I'm starting it in a strip. So it starts randomly along this line. It's actually line. I'll show that in a minute. And I'm using Perlin noise. And you'll see I exposed a bunch of variables here. And the noise amount, you know, I played around with this, and it always, and maybe I'm not feeding the coordinates in correctly, you know, it generally wavers back and forth. And maybe that's the look you want. It's not terrible. It tends to follow a very similar pattern. You know, and if you maybe make the ribbons, you know, really wide, lower the rate so there's, you know, not as many coming out. You know, it's pretty good. It's not terrible. Again, it's just a different look, and kind of knowing all the different options that you have sometimes can help. It does suffer from that, you know, using the strip, you'll notice they start here and grow longer before they start moving. So again, moving, you know, this back off of your scene, so by the time they hit the visible part of your scene, that they're already fully extended, can help that. Again, it does, you know, create more of a straight line. The other issue is you'll notice, well, if I set their lifetime, you almost gotta make them this is the lifetime of the particles, so they get all the way off your scene. Actually, I think that's because of, nope, there they go. Took a while to catch up. So you'll want them to go off the visible area, because again, they kind of shrink. You'll notice, you saw that one kind of shrinks at the end because the particle stops moving here, and then the strip just keeps getting shorter until it disappears. So again, different look. Can take a quick look at what that VFX graph looks like. So here's my Perlin noise. One thing to notice just reading the manual is that these octaves, the higher you go, the more work it takes. So if you got a lot of particles, you want to keep that low. I'm essentially using the noise amount and using that to divide by the position. So I take the position, the XY position, and I divide it by the noise amount because it basically slows down how fast it moves across the noise. The faster it moves across the noise, the faster the wiggles back and forth are. The slower it moves, the more spread out your waves are going to be. So I take that position. Again, I feed the position into the X and Y values, and then I use that. So basically the Perlin noise, it's a 2D noise, and the coordinate is going to choose what value from the noise. If you look in the Unity manual, it has a pretty nice explanation of this and a picture to go with it. So I won't go into those details, but you can look at that manual. For once, it actually was somewhat helpful. I noticed the manual doesn't help me a whole lot a lot of times. And this range I use to feed into that range between a negative and positive value. You need to keep it really small. It's at 0.01 because this is adding to the position of the X. And you'll notice that the particles, the frame rate's pretty high. And if you add too big of a number, it just goes crazy. So this number has to be pretty darn small. Otherwise it gets out of control. And then I just set a velocity based on that speed. So they're just pretty much going straight and moving back and forth in the X direction by this Perlin noise value. And the strip is pretty much the same as my previous one. I really just took each one of these, copy and pasted, kept the things I wanted, and changed the things I didn't. So that's pretty much that noise one. So the last thing I was going to use is turbulence, and I've used it before. It's actually a pretty cool effect, and I thought it would work pretty well with my smoke. So I'll show that next. So for my last effect, I'm using Turbulence. And I'm kind of using the same start as I did before. And I didn't show that before, so I'll show that this time. I'm launching it based on a line. And I am basically setting a velocity. And then I have turbulence that will kind of give some variance back and forth. It does always... It uses all three X, Y, and Z coordinates in order to do the turbulence. And so I control that. There may be another way to do it. I haven't found a good way to put a filter on that. But I did find some ways to control that a bit, and I'll show that. So if I select this again, have some variables exposed. This intensity, if you move that up, will change how much the variance uses. And you'll see if I make it up really high, it just kind of goes crazy, right? Some are behaving themselves, and a lot are just going crazy, even looping around themselves. So you want to keep that pretty low. If you want them basically always to keep moving in this direction, but just kind of waver back and forth in a nice pattern, and that actually looks pretty good. I was pretty happy with it. Some challenges are that I had to make the lifetime go way off my scene, and the reason is because the turbulence can also slow down, so it can go in the Z direction. And so some of the particles will go really slow, and they actually end right in the middle of your scene, which does not look good, because then as we saw before, and you'll notice one just did it there, and some are doing it there. So they just kind of stop in the middle because it kind of slows the Z direction way down, and then the particle never reaches its destination. Some also go off kind of in crazy angles, which may be good, may be bad. It's a problem with turbulence. And I didn't play around with it that much to try to do anything else to kind of rein it in, to keep it kind of within the boundaries that I wanted to and not do the Z direction. But the one thing you do need to do is control the Y direction. And I'll show that here. If we drag this on here, we can see the VFX graph. So I'll show, let's see. Yep, this is my particles. So this set position, so this is the start position, is going to be line and in a random. You can also there's also a line that does equally spaced. I didn't play around with that because I just wanted the random particles coming off in a line. And if we select that and go back to our scene, Nope, not going to be able to show it here. I'd have to have it both on the screen at the same time. But you can actually change the coordinates of that line through your screen. Actually, I think it's because maybe that's, nope, that's not it. I want to show it bigger just so I can see everything. But you can set the coordinates of that line, and you can set them. These are just the coordinates of the begin and the end point of that line. So I control the lifetime there. I control the speed there. You need to use a velocity. You can't set the position using turbulence. You have to give it a velocity because the turbulence works within here. And you can't, the turbulence has to be within, from everything I can see, in one of these blocks, in the update particle. You can't use it as a separate node and just feed its position or add its position or anything. So here's the turbulence. Again, I feed in that intensity. Similar things to the purlin noise. You can choose the type of noise that you use to control that. And then you have these other variables. Again, the manual does define these. I didn't play around with them. I know that the octaves make it more random. It goes through more iterations. Again, the intensity really is one of the key ones. Didn't play around with some of these other values, but you can just to see kind of the result of what you get. Same triggering of our ribbon, that's exactly the same. This is important. You'll notice that this position, I'm taking the current position and I'm just passing the X and Z through, but I'm multiplying the Y times 0. And if we don't do that, this is what happens. It starts taking off in the Y direction because the turbulence is affecting the Y just like it affects the X and Z. So we don't want that. So by multiplying the Y of the position by 0, we're basically zeroing out any Y movement, and I want it flat. I don't want it going up and down in the Y direction anyway. The other thing I do is that, again, that Z velocity, so this is affecting the velocity. And what I do is anytime the velocity, I compare the velocity, and if it is less than 0.1, meaning it's slowed way down, then I add 0.5 to it. And I could change these values and mess around with them, but essentially what I'm trying to do is say, I don't want the velocity to get too slow. I want to keep it moving forward. And this was a way to do it. It does help. If I didn't have this, I would get a lot of them kind of stopping in the middle and not looking good. So this was my attempt to keep them moving in the forward direction. So that's pretty much the important parts. The other parts are exactly the same as some of the other ones. Again, I just copy and pasted this, kind of remove the purlin noise, put in the turbulence to see what we got. So, you know, I'm not sure. I think this would be one of my favorites, and it works pretty well. And if you play around some of those values, you get that more drifting smoke moving across, and the turbulence does give it a nice back and forth movement in a fairly random way. All right, so that's pretty much all my smoke. We did our smoke on the arch. We did the smoke across the floors. Trying to figure out what I'm going to do next. Thinking I've been obsessed with trying to get a good fireball. I got some decent flames, but I was just not able to get kind of the look. And if you look at a lot of the fire explosions in games, they're just pretty bright. And I mean, just doing a bright explosion is really easy. But doing a nice fireball that's kind of red and orange and black along the edges, I found it tough to do. So I might see if I can get that working. If I make a pretty good looking one, I'll do a video on that. Otherwise, I was also thinking of this smoke effect's cool, but wouldn't it be cooler if it could move over a non-flat environment. And you can't do that with the particle system, but you can make it move along the surface. I have done it similar with another situation, and I thought that would look pretty cool, as if it kind of, floated down steps or over the edge of a cauldron and kind of flowed down over the scene. So I might do that if I fail at making a good fireball. So again, keep watching, if you really like these videos, and I hope you do. And again, my focus is to learn, not necessarily make super cool effects. Other people do better looking effects, but hopefully by explaining this, it allows you to figure out how to put together your original effects. Because, the way I see it is, if you wanted some cool effects, I can go buy some effects packages and put it in the game. The reason I do what I do is I want to learn how to do this because I want to make my own, and I want them to look cool, and I want to use my creativity to make the effects I want. So again, I hope you learned something on this video. Try it out yourself and keep watching for the next one.